In this video, I'm going to show an example of finding the derivative using the chain rule, otherwise known as finding the derivative of a power of a function. And so this is what the chain rule looks like. The derivative of a function y with respect to x, dy dx, is equal to dy du multiplied by du dx. Now let's have a look at what that means. This means the derivative of a function y with respect to u. So the variable in the function is u. And this means the derivative of a function called u with respect to x. So the variable is x. Now let's have a look at an example of a function. So we've got here something like y is equal to 6x minus 2. Now that we could just do as a polynomial. You've been able to find derivatives of that. But if we raise it to a higher power, something like 4, and it is not favorable to multiply this out by itself 4 times. So there needs to be another way to find its derivative. So let's take this approach with the dy du. If we could write the function y, this is the function y, with respect to u, meaning if we call everything in the brackets u. So let's do that. Let's say u is equal to 6x minus 2. That changes what y becomes, because now we've got a way to express our u function in terms of x, but let's express y in terms of u. So this leads us to y now is equal to, well, if all of this is u, it's equal to u to the 4. So where we have to find the dy du, we have to find the derivative of the function y with respect to u. Then this leads us to the derivative of this function will be, so the dy du is 4u cubed. Alright. Now the other part of this chain rule is the derivative of u with respect to x. Since we already have u with respect to x, let's find the derivative of u with respect to x, which means take the derivative of this polynomial right here, which is equal to 6. So we do have, let me see now, another color, all right? So for the du dx, we do have, we have du dx right here. And dy du, we've got that as well. Dy du is 4u cubed. Alright. The other thing is, this original function was in terms of x, so we should actually write our dy du in terms of x. So subbing back in what u is actually 6x minus 2. So this becomes 4 times 6x minus 2 all cubed. That's 4u cubed. So the derivative dy dx is 4 times 6x minus 2 all cubed, that's dy du, multiplied by du dx, which is 6. So since we're not going to raise this to the power 3, then the only way we can simplify this is take this coefficient and multiply by this value, so this actually becomes 24 6x minus 2 all cubed. Okay, let's have a look at, some people refer to this in a slightly different way, but it actually does the same thing, and I think this might be helpful. They refer to the chain rule as being the derivative of the outside function multiplied by the derivative of the inside function. So let's write it that way because some people might like that. The derivative of outside function multiplied by the derivative of the inside function. And then we take those two, multiply them together, and we get the dy dx. Okay, so what is this outside function? Let's examine this again. Our function was y equals 6x minus 2 all to the 4. The outside function is the fact that we have something all to the 4. So we have a thing to the 4, and the derivative of that outside function is 4 multiplied by the thing to the power of 3. And the inside function is what's inside the bracket, that thing I was referring to with such an odd name, but that's just one way to refer to it. So the derivative of what's inside. So dy dx. If we find the derivative of the outside function, 4 becomes the coefficient. Don't change the bracket and reduce this by 1. So the bracket remains unchanged, 6x minus 2. Multiply by the derivative of the inside function, what's inside the bracket, which is actually 6. And multiplying 6 by 4, okay? So if you want to word this in your resource booklets, it might look like take the power, it becomes the coefficient, leave the bracket alone, reduce the power by 1. Go back and do the derivative of what's inside the bracket. Okay? There's an example for you, and I hope that's helpful.